Hi guys, welcome to another maths tutorial brought to you by Direct Tutoring. Today we're going to have a look at a run through of the 2017 National 5 past paper. Now we'll go through the entire paper 1, so that's a non-calculator paper in real time, and you can see our thought processes and how to solve every question with an in-depth solution. So we will just dive straight in and we will have a look at question number 1. Now again, you do get your formula sheet, so we will refer to this throughout the paper, but here we'll just take a look at question number 1. So it gives us a function of f of x is equal to x squared plus 3x, and it wants us to evaluate f of minus 5. So what we can see is that the x here has been replaced by minus 5. So all we need to do is rewrite this equation and replace x with minus 5. So here we'll have x of minus 5 equals, now we're going to have, wherever there's an x, we're going to replace it with minus 5. So we'll have minus 5 squared plus 3 times minus 5. So then minus 5 squared will be plus 25. Then it's going to be 3 times minus 5 is going to be minus 15. So 25 take away 15, the value becomes 10. So your 2 marks come from substitution of the minus 5 and then actually carrying out the calculation. Now number 2 is, this gives us the number of calls received by the police recorded at over 10 days, and we need to determine the semi-interquartile range. So the first thing that we need to do here is find the each quartiles and find out what the interquartile value is. So here we'll just put 1 and 1. Now these are already in order, so that makes it a bit easier. If these weren't in numerical order, i.e. smallest to the largest, we would have to maneuver these values into that order, but so far they're already in ascending order. So we'll just go 1 and 1, then this will be 2 and 2, 3 and 3, 4 and 4, 5 and 5. So that means that our individual quartiles is, this is number 1 and this is number 2. So we can see that Q1 in this case is going to be 218, and we can see that Q3 is going to be equal to 250. So we know that the semi-interquartile range is going to be the value of Q3 minus Q1 divided by 2. So we can do 250 minus 218 divided by 2, and that will give us a value of 16. And that's how you would go about finding the semi-interquartile range of this data set. Now the reason this is Q3 is because Q2 is the mean of these data set. So that's why semi-interquartile range is the difference between Q3 and Q1. Now question number 3 is a nice simple fractions question, so only 2 marks. So the first thing that we'll do is we will convert our mixed numbers into our top heavy fraction. So in order to do this, we have our 1 and then 5 over 6. So to get this as top heavy, what we do is we take the 1 multiplied by the 6, then plus the 5 on the top. So here we would get 11 over 6, and that's this rewritten as a top heavy fraction. So what we can then do is replace this with 11 over 6. So we'll have 11 over 6 divided by 3 over 4. Now when we divide fractions, remember we flip the second one upside down, and then the divide becomes times. So we have 11 over 6 times 4 over 3. So then we'll have 11 times 4, which is 44, and then we have 6 times 3, which is 18. Now what we can then do is start to simplify this. So the first thing that we can see is that we could divide these by 2, top and bottom. So that would give us 22 over 9. Just like that, and that cannot be simplified any further. You could put that into mixed numbers if you want. So what we would say is, how many times can 9 fit into 22? So we would say that this would be 2, because that would give us up to 18. And then the difference from 18 to 22 is 4. So it would be 4 and then 9 on the top. And that would be your final answer in its simplest form, just like so. Now number 4 is we need to expand and simplify these two brackets. Now the first thing that we will notice here is that we have a bracket with 2 terms and then a bracket with 3 terms. So when we have a bracket with 3 terms, we cannot use FOIL. FOIL only applies to 2 brackets multiplied with 2 terms inside them. So what we'll need to do is take each of these terms individually, multiply it by the bracket with the 3 terms, and then add them all together. So we'll do 2x multiplied by x squared minus 4x plus 1. So we'll just multiply this out as a standard multiplying out the brackets. So 2x times x squared will give us 2x cubed minus 2x times 4x will give us 8x squared plus 2x. Then what we will have is we'll do the 3 this time, so we'll have 3 multiplied by x squared minus 4x plus 1. So that will give us 3x squared minus 12x plus 3. So now what we'll do is we will add these 2 new equations together because it's add in here. So we'll do our 2x cubed minus 8x squared plus 2x plus, and then I'm going to put this in a bracket because we have a minus in here. So this plus will apply to every single term. So we'll have 3x squared minus 12x plus 3. So then if we tidy this up, we've got 2x cubed. We've dealt with the cubed, so we can tick them off. Then we have our x squared, so we have minus 8x squared plus minus 12x. Minus 8x squared plus 3x squared. So that would give us minus 5x squared. So we've dealt with the x squareds. Now we then have 2x plus minus 12x. So that would give us minus 10x. We've dealt with all the x's, and then the plus 3 will just sit by itself. And that is your final answer. Now, number 5 is a little bit harder, but if we take our time, then we should be okay with this style of question. It can be a bit tricky to get your head round at first, but let's have a read at this and see what we think. So we have a square-based pyramid placed on top of a cube relative to the coordinate system's axis. So this is a cube here, and then we have a square-based pyramid on the top. Now we know that the height of the pyramid is half the height of the cube. So from this point here, so this is the top of the cube. So from the top of the cube to the point C, this is half the height of the cube. And we know that from this point to that point is a value of 6. Now if it's a cube, all the sides are the same. So that means that this length is 6 and this height here is also 6. So that means from this point here to that point there is a value of 3. Now it gives us point A, so that allows us to work out the lengths of the cube, so 6, 6, 6, and then we have our 3 up here. So we now need to write down the point C for its coordinates. Now C is directly in the middle of this entire shape. So if we draw all the way down through and we touch this point here on the base, we can see that the coordinates of C, now I'll just write them at the side here, so the coordinates of C, we go along, in, then up. So it's going to be half, so it's going to be 3, because it's directly in the middle. Then if we go in, it's going to be 3 again, because it's directly in the middle. But this time, it's at the apex of your pyramid, so it's going to be the 6 for the cube, and then the 3 for the pyramid itself, so we get a value of 9. And that's how you go about annotating a graph like this. Now the other coordinate that we need to do is we need to write the coordinate of B. So we find the coordinate of B, that is here. So under here we'll just write B. Then B lies on the Z and Y axis, so it doesn't come along in the X at all. So that means the X value is 0. Now B is at the further end of the cube, so that means it's going to have an in value, a Y value of 6. And then it goes from the base all the way up to the top of the cube, which is a value of 6 as well. So we have 0, 6 and 6. And that's your coordinates of B. So again, only 2 marks. You get a mark for C and a mark for B. Now question 6 is the diagram below shows the straight line joining points A and B together. And we need to find the equation of this line. So nice and straightforward. So when we find the equation of a straight line, we need 2 things. We need the gradient and we need a point. So the first thing that we'll say is, do we have a point on this line? Yes, we have A and we have B, so we have that. The thing that we need here is the gradient. Now, one thing to note is, as I tell all my students, before you dive straight into the gradient equation, what you can do is give yourself a value to kind of aim for. So we can see that the gradient of this line is going to be negative because we have a negative slope. So when we carry this calculation out, if we get a positive value, we know we have done something wrong. But let's go through it and let's see what value we get. So your formula for your gradient is going to be y2 minus y1 over x2 minus x1. Now before you start substituting values in, because it's very, very easy to make a mistake, the best thing to do is to label your points x1, y1 and x2, y2 first. So I'm going to make this one the 1s and I'll make this one the 2s. So this is x1, y1 and this will be x2 and y2. So let's substitute these values into this equation and we'll tidy it up. So we have y2, which is minus 2, minus y1, which is 6, divided by x2, which is 3, minus x1, which is minus 1. So minus 2 times minus 6 is minus 8, divided by 3 minus minus 1, so that minus minus 1 becomes a plus, so that becomes 4. So would you believe it, our gradient becomes minus 2. So that fits what we expect. Because we have a negative slope, we expected a negative gradient, which is perfect. So now that we have our gradient, I'll just scroll down here, we then use our equation of the straight line, which is y minus b equals mx minus a. Now we have m and we also have a and b, but we just need to decide which coordinate we're going to use. Now I'm going to use coordinate a. So the x value is a and the y value is b. So we'll just substitute it in here. So y minus b is 6 equals, our gradient is minus 2, x minus, and a is minus 1, so it's going to be minus 1. So if we tidy this up, we'll get y minus 6 equals, now minus, in fact I'll do the extra step, so minus minus 1 becomes plus 1. So then we can multiply this bracket out. So we get y minus 6 equals minus 2x minus 2. We'll then bring this 6 across to the other side, so that means we're going to have to plus 6. So that'll be y equals minus 2x plus 4, because we'll have 6 take away 2, which is 4. And that is your equation of that straight line there. So again, 3 marks. We get a mark for the gradient, we get a mark for writing the equation, and we get a mark for the final answer. Now question number 7 is we need to calculate the area of this triangle. So again, remember this is a non-calculator question, so they won't expect you to be able to do like the trigonometric values off the top of your head. So that's why they give you this sine e value is 2 over 3. Now if you're unsure about the equation of the straight line, what we can do is if we scroll back up to the formula sheet, we can see that our equation of the triangle is a equals a half ab sine c. Okay, so what we'll do is we'll write this down. So a equals a half ab sine c. Now here we can say that this value in here, so sine e is talking about this angle in here, and we know the value of sine e is 2 over 3. So it's really just a case of different nomenclature. So we have a, b and c, here we have d, e, e, f and e. But the theory is still the same. A and b are lengths. We have lengths of 8 and 12. So we can make this a and make this b, which means that would, instead of being sine e, would be sine c. So if we substitute these in, watch what's going to happen. So we have a, which is going to be 8, multiplied by b, which is going to be 12, multiplied by sine c. Now sine c, we know the value of that, which is 2 over 3. So we'll times that by 2 over 3. Now let's see what happens. So the first thing that we can do is, because there is no definitive way on which you should basically carry out this calculation, it's entirely up to you. So the first thing that we'll do then is we'll have a half times, then we could combine these together. So at the side, if you want, 8 times 12, so 8 times 2 is 16, 8 times 1 is 8 plus 1 is 9, so that's 96. So you could have 96 over 1 times 2 over 3. So here we could do half times 96 over 1, so that would be 96 over 2 times 2 over 3. Now watch what happens here. A small trick for you to watch out for is this 2 here is going to cancel with this 2 here. So what you could do is eliminate these and have 96 over 1 times 1 over 3. So that becomes 96 over 3, which is nice and simple because 9 divided by 3 is 3 and 6 divided by 3 is 2. So your final answer here is 32. Now do we have any units? Yes we do. So this would be centimetres squared. So again, that's just a nice trick in order to keep the values nice and low, because otherwise we would be doing 96 times 2 and then we'd be dividing that by 6. So that could be a bit tricky for some people. So again, if we can see that these 2's are going to cancel, it makes life so much easier. But that's how you go about solving that kind of question there. So again, it is only worth 2 marks. You get a mark for the substitution into the equation, and you get a mark for this bit here. Now again, if you forget your units, you may be penalised an entire mark, so just always be sure of your units. Now question 8 is we need to solve algebraically this inequality. Now an inequality is the exact same as a general algebraic equation. So a lot of my students seem to struggle when they see the inequality. But an inequality is simply a range instead of a definitive answer. So for example, if I was to say that x equals 5, then that is a definitive answer, that I know that x is 100% 5. However, if I say that x is greater than 5, I'm referring to every single value possible that is greater than 5. That's what an inequality is, compared to a definitive equal value. So this, it just gives you a range. So again, we're just going to solve this as we normally would. We're going to multiply out this bracket first, and then we'll just get all the numbers on one side, and then we've got all the letters on the other side, and then we'll eventually get an inequality that looks something like this. So we'll have 19 plus x is greater than 15 plus, then it's going to be 3x minus 6. So what we can then do is have 19 plus x is greater than, so we'll have our 3x, and then we'll have 15 take away 6, which will give us 9. So then what we can then do is bring this plus 3x across to the other side, and then this 19 across to that side. So this would go over as negative, and this would go over as negative as well. So what we end up with is x minus 3x is greater than 9 minus 19. So now we can do x minus 3x, which is minus 2x, is greater than 9 take away 19 is minus 10. So then what we then do is divide by minus 2. Now when you divide by a negative number with an inequality, the sign reverses. That's the one key rule you must remember. So x is going to be less this time than minus 10 divided by minus 2. So x is less than 5. And that's how you would go about solving your inequality equation. So that just gives you the range of x values. Now question number 9 is a angles question. So it says that ABE, so A, B and E is a tangent to this circle, and DBE is 58 degrees. And we need to calculate the angle size of CAB, so that's this shaded area here. So we have this triangle in here like so, something like that. So the first thing that we will try and do here is we will look to analyse the lines around the information that we have, because we have nothing on this triangle, but we do have something around the 58. So what we could say here is that we have, in essence, this is 90 degrees in here. So we know that this angle would be 90 minus 58. So OBD, so we could say that OBD is equal to 90 minus 58. So 90 minus the 58 would be 32. So that means that in here, this angle is 32. Now what we have as well, or what we can start to play about with here, is X and F angles. Because we know that from an X and F angle perspective, we can say that O, C and B, because this here is 58, so this is a reflection in this axis. So if this is 32, or in fact what we could do then is, if this is 32 and this is 32, then this is an obtuse triangle, so we could say that 32 plus 32 is 64. Now this angle in here is going to be 180 minus 64. So what we'll do is we'll say this is 7, then this is going to be 6, this is going to be 10, sorry, this is going to be 1, and then that's going to be 1. So in here is 116. Now by the same logic, what we can then say is that if we do the, for this angle in here, if we do 180 minus 116, we know that this angle must be 64. So then, what we can then say is that the total amount left in this triangle is 116. So if we do 116, because this angle in here and this angle in here are identical, so if we do 116 divided by 2, we get a value of 58 degrees. So in here is 58 degrees, and in here is 58. So we're annotating the entire triangle here. Now we know that in this section is going to be 180 minus 58. So this angle in here will say that we have 180 minus 58. So again we'll cross this out, 7, 2, 2, so that there is 122. So what we'll then say in here is 122. Now this angle in here must be the combination of 58 plus 58 plus 32 minus 180. So that means in here, this value is going to be 32. So 32 in here. Now that means that our unknown value in here is going to be, so C A B is going to equal 180 minus 122 plus 32. So that is going to give us a value of 26 degrees. So that's how you go about annotating this entire system in order to find the value of CAB. Then that's this angle in here. And again, we can do a check. We know this is an acute angle, so we know it has to be less than 90 degrees, which in this case, it is indeed. Now question 10 is a nice easy change the subject of the formula, and this time it is to B. So we'll write out our formula. So it's F equals T squared plus 4B over C. So the first thing that we'll do is we'll take this C across, and this will go over as times. So we'll get FC is equal to T squared plus 4B. Now the next thing that we'll do is we'll get rid of what I would call the loose ends. So nothing is attached to the B, because B is a thing that we are trying to isolate by itself. So I'm going to take this T squared across to the other side. I'm taking the entire thing. So this is going to go over as minus, because it's plus on this side, so it's going to go over as minus. So we have FC minus T squared equals 4B. Now all I'm going to do here, I'm going to rewrite this the other way, so that I have B on the left hand side of my equal sign. So I'm not doing any manipulation, I'm just moving the equation around. So I've got 4B is equal to FC minus T squared. Now the final step is to get rid of this 4. So in order to do that, it's timesing the B. So if we divide both sides by 4, our equation becomes B equals FC minus T squared, all divided by 4. Again, you could divide these individually, but then when you combine them with the laws of fractions, you would have the common denominator on the bottom, so it would be FC minus T squared, all divided by 4. And that's how you go about changing the subject of the formula from F to B. Now, question 11 is we need to express 3 over a squared minus 2 over a as a single fraction in its simplest form. So we have 3 over a squared minus 2 over a. Now in order to combine fractions, or take fractions away, we need a common denominator on the bottom. Now we could make life hard for ourselves and do the kiss and smile method, but then we would end up with like a cubes. Whereas what we can do here is this is a and this is a squared. If we times the second fraction by a, then we get a squared on the bottom. So we would have 3 over a squared minus, then it's going to be 2a over a squared. So then we have a squared on the bottom, so therefore we can take these values away. So we get 3 minus 2a over a squared. And that is it. 2 simple marks. We get a mark for this and a mark for this. Again, you could do the kiss and smile, and then you would find out that your a's would cancel out as well. So it just depends on the type of system that you are going for. Now question 12 is we have gym members are asked to fill out questionnaires and rate their quality of the service, and they're asked to give their ratings from a scale of 1 to 6, and this was the ratings of the 5 members. Now in its simplest form, the standard deviation of the ratings can be expressed as a root b over 2. So we need to find the values of a and b. Now the key words here is standard deviation. So what we can do is, if you're ever unsure, we'll scroll back to our standard deviation equation in the formula sheet. Now we have 2 different ones that we can do, but for me I'm going to use this one here because it's slightly smaller. So we have s is equal to the square root of the summation of x minus x bar squared, all divided by n minus 1. So again, I'll scroll back down and we will begin to solve this. So we know that s equals the square root of the summation of x minus x bar squared over n minus 1. Now the first thing here is that x bar is the mean value. So we can find x bar to be add up all the values and then divide by how many values we have. So we'll have 1 plus 4 plus 6 plus 3 plus 6, all divided by 1, 2, 3, 4, 5. So if we do 6 plus 4 is 10, 6 plus 3 is 9, plus 1 is 10, so that's 20 divided by 5, so that will give us a average value of 4. So then what we then have to do is find the summation of each of these values minus the average value squared. So what we'll then do, and then n of course is going to be 5. So n is going to be over 5 here. So we'll create a table here of x minus x bar squared. So we know our x value, and then we'll have x minus x bar, and then we'll have our x minus x bar squared. So that's our table here, like so. So we have our x values is going to be 1, 4, 6, 3 and 6. Something like that. Now we're going to do our value minus the 4. So 1 minus 4 is minus 3, 4 minus 4 is 0, 6 minus 4 is 2, 3 minus 4 is minus 1, and 6 minus 4 again is 2. So then what we do is we square this value. So this value here, we square it. So here we're going to get 9, 0 again, we're going to get 4, we'll get 1, and we'll get 4. So let's add this up. So we get 9 plus 1 is 10, plus 4 and 4 is going to be 18. So the value here that we want is 18. So now what we can do is substitute this into the equation. So it's going to be the square root of 18 divided by n minus 1, which is 5 minus 1 is 4. So we're almost there because we've now got it to kind of look like this. So what we then have to do is we square root the top and the bottom individually. And hopefully, if we've done this right so far, we should get 2 on the bottom, because here our final answer should be 2 on the denominator. So we'll have the square root of 18 divided by the square root of 4, which thankfully the square root of 18 is a surd. However, the square root of 4 is 2, so we know we're on the right track. Now the square root of 18 is a surd. So what we'll do is we'll do solving surd, so we need two numbers that will times together to give you 18, one of which should have a complete square root. So we'll go for 9 times 2 divided by 2. So we'll split these apart, so we'll have the square root of 9 times the square root of 2 all over 2. So then what we'll get is 3 root 2 over 2. So now we will compare this with this, so we can see here that our value of A is 3 and our value of B is 2. So quite an involved question, but if you follow the process of the standard deviation carefully, draw out your table, and then just start to compare your equation to the one that is given, and then notice that this is a surd, solve using surds, and then compare your final answer in that form, and that will give us A and B respectively. Now question 13 is we have a graph that shows two straight lines with the equations 3x minus y equals 2 and x plus 3y equals 19. And we need to determine the value of P, which is the point of intersection of both of these lines. So as soon as you see a question like this, the point of intersection of two lines, the first thing you should be thinking about is simultaneous equations. So we can solve simultaneous equations in two ways. You can solve them by substitution, which is you rearrange one of the equations, so y in terms of x, and substitute it in, or you can do it by elimination. which is when you stack them on top of each other, make one of the variables the same, and start to cancel out. So for me, I'm going to do the elimination. So we're going to stack these on top of each other. So we'll have 3x minus y equals 2, and then we'll have x plus 3y equals 19. So the first thing I'm going to cancel out here to make life easy is I'm going to cancel out the y's. That way I don't need to start multiplying things by 19. So I'm going to multiply, in order to get this to the same value as this, I'm going to have to multiply this by 3. So then I'm going to get here 9x minus 3y equals 6, and then this equation is going to remain the same. So x plus 3y equals 19. Now what I'm then going to have to do is, in order to cancel these out, I just need to add them together. So if I add these together, top and bottom, so if I do the top plus the bottom, I will get 9 plus 1, so that's going to be 10x. These will cancel each other out, and then we'll have 6 plus 19, which will give us 25. So we'll have x equals 25 over 10, in which we can simplify this further. We can use 5, so here we'll get 5 over 2. So that's our value of x. Then what we can then do is sub the value of x equals 5 over 2 into any of these equations that we want. Now for us, the easiest thing to do here, because this is us trying to find the value of y, the best equation I would say to use is this one here. So what we will then do is we'll say that we have 3x minus y equals 2. Now I'm going to rearrange this so that I get y by itself, but I'm going to take this y across here and make it plus. So I'll get 3x is equal to 2 plus y. Then I can take this 2 across and bring it beside the 3x. And then if I rewrite this, I'll get y equals 3x minus 2. So then all I have to do now is do y equals 3 multiplied by 5 over 2 minus 2. Y equals, so if I do this, that'll be 15 over 2. Like so, minus 2 over 1. So then if I do y equals, then it'll be 15 over 2 minus 2 over 1. So I'm going to have to multiply top and bottom of this by 2 in order to get a common denominator on the bottom. So we get 15 over 2 minus 4 over 2. So y equals is going to be 11 over 2. So the coordinates of P, while not very nice, is 5 over 2 and 11 over 2. And that's how you would go about solving the simultaneous equations in order to find the values of P. Now question 14 is we have a graph that shows a parabola with the equation of y equals x plus a squared plus b. Now this is in the completed the square form, so this makes it a lot easier to read off the answers. So here all we have to do is state the value of a. Now the value of a, this relates the turning point, so a and b are the values of the turning point. So a is the value of basically the value of the turning point, but it's the opposite sign of the x value. So we know that x here is minus 5. So we need the corresponding value of x that would make this bracket equal 0. So the value of a, in this case, is going to be plus 5. So a equals plus 5. Now part B is we then need to calculate the value of b. So what I'm going to do, I'm going to rewrite this equation, but I'm going to substitute in my value of a this time, because I know that a is 5. So we have y equals x plus 5 squared plus b. Now as it stands, in this equation we have 3 unknowns, and we need to find b. So that means we need to know an x and a y value in order to find the value of b. So here we have our value of x and we have our value of y. So let's substitute this in and let's see what happens. So we know that y is 8, and that's equal to x is minus 3 plus 5 squared plus b. So 8 equals minus 3 plus 5 is 2 squared plus b. So 8 equals 2 squared is 4 plus b. We'll take that 4 across to the other side, that will go over as minus. So 8 take away 4 is 4 equals b. So b is equal to 4. And that is as difficult as those questions get. And then finally, the last question in this paper is a similar shapes question, whereby we have a diagram with two triangles. The TS is parallel to QR, and TS in this case is 5 and QR is 7. SR from this point to this point is 2.6. And we then need to find the length of PS in centimetres. So what we can then do first here is we'll draw out the two triangles. Now they're going to be very, very rough here. Very rough triangles. But we'll have this is 5 and this is 7. This is X. And this for the whole triangle, so QPR, this is going to be 2.6 plus X in here. Now you can call these, for your scale factor, new over old. Either one you can make the new and either one you can make the old. It doesn't really matter. So what we'll do here is we'll say that this is the new and this one here is the old. So the first thing that we can do is get the scale factor of these two parallel lines, the 5 and the 7. So we know that the new over old is going to be 5 over 7. And that's then going to equal the same ratio between these lengths here. So that's going to be the new divided by the old. So that's going to be X over 2.6 plus X. So then what we can then do is cross multiply these. So we can do 5 bracket 2.6 plus X is equal to X times 7. So then what we'll do is we can have 5 times 2.6. So again, if you aren't 100% sure, you just do 2.6 times 5. So keep the decimal point here. 5 times 6 is 30. 5 times 2 is 10, so that'll give you 13. So here we get 13 plus 5x is equal to 7x. So then we'll take this 5x and bring it across to the other side. That goes over as minus, so you have 13 equals 7x minus 5x. So I'm just going to finish this up here. So 7x take away 5x is 2x, and that's going to equal 13. So then we divide by 2, so 13 divided by 2, x is going to equal 6.5. And that's how you would go about solving that kind of question there for similar shapes using some algebraic techniques in there. So that is the end of the 2017 past paper for the non-calculator section. So thank you for watching. In the next video we're going to take a look at the same run through for the 2017 paper 2 for the calculator. So we'll hope to see you there.